This lesson is on manipulating equations and formulas to isolate a given variable. The steps involved here for solving for a variable. The first thing you want to do is locate the variable you are asked to solve for in the equation. Then identify the operations on this variable in the order in which they are applied. Finally, use the inverse operations to undo operations and isolate the variable. Not unlike solving an equation when we have one variable, but in this case we're solving an equation when we may have two or more variables. Here are some examples. In example 1, we have x plus y equals 15, and we're asked to solve for x. So we locate the x, and then we take y, subtract it from both sides, and we get x equals negative y plus 15. In our second example, pq equals x, when we're solving for q, to get q by itself, the only thing we need to do is divide both sides by p. Our result is q equals xp. Notice in both of these examples, we're not coming up with an answer for x or an answer for q. We're coming up instead with an expression for both of those involving the other variable. Q is an expression involving x and p. For x, the expression was involving negative y and 15. Sometimes we'll be solving something called a formula. And a formula is an equation that we use with standard for the same situation all the time, like a formula for area or a formula for converting Fahrenheit into Celsius. These are formulas. So here we have the formula for the area of a triangle, A equals 1/2 base times height, where B is the length of the base and H is the height. And we want to solve for H in this case. So we have A equals 1/2 BH. The first thing we want to do is multiply both sides by 2. This eliminates that fraction 1/2 and gives us 2a equals bh. Notice on the next step in red, I now divide by b. I'm dividing both sides by b, and this is giving me h all by itself. So if I knew the area and the base length of a triangle, I could figure out its height by using this reworked formula. Height equals 2 times the area divided by the base. An important point I want to make for all of these types of problems, remember when we're dividing by a fraction, it's the same as multiplying by the reciprocal. In the previous problem, we had 1/2 base times height, so what did? We multiplied both sides of the equation by 2, or 2 over 1, the reciprocal of 1/2. Here's another example. Here we have the formula speed is equal to w minus 10e over m, where S is speed per minutes, W is number of words typed, E is number of errors, M is number of minutes typing, and we want to solve for E. So this is an equation that figures out the speed at which you're typing. Okay, so we locate E, it's over there next to the 10. And we want to say, okay, how do I get that isolated? There's a lot going on here. Well, I recognize that there's a fraction bar, and a fraction bar is a grouping symbol. So the first thing I want to do is get that m out of the denominator so I don't have to deal with fractions anymore. So I multiply both sides by m. Now I have ms equals w minus 10e. Well, moving far away from the e to close to the e on the same side of the equation, that w is the next thing I want to deal with. Now you might notice that there's being subtraction done, that w is involved in subtraction with the 10e. But the key here is the w is positive, so we want to subtract it to undo it. So we subtract w from both sides, and then we're left with ms minus w equals negative 10e. So how do I get that e by itself? Well, the next step is simply divide both sides by negative 10. And then I get my equation all by itself. Here you can see ms minus w divided by negative 10 equals negative 10e divided by negative 10. Therefore, ms minus w over negative 10 is equal to e. Here's one more example. The formula c equals pi d gives the circumference of a circle, c in terms of the diameter d. The circumference of a bowl is 18 inches. What is the bowl's diameter? And we want to leave it in terms of pi. Well, because our equation doesn't solve for diameter right now, our equation instead solves for circumference, we need to figure out, okay, how do I solve for diameter when given circumference? So c equals pi d. What am I going to do? Well, I'm going to divide both sides by pi. So c divided by pi equals d, or d equals c divided by pi. Okay, well, now that we've rearranged our equation, let's use it. So 18 is our answer here, is our circumference here. So we plug in 18 for C, and we find out that D is in fact 18 over pi. And that's an answer in terms of pi. So we can leave it right like that. 18 over pi inches is our diameter. I know it doesn't seem terribly satisfying to leave it that way. What's key to remember here is that before we might not have known, well, are we supposed to do 18 pi, 18 divided by pi divided by 18? So reworking the formula or the equation first gives us an easy way to sort of see at the end in the answer, okay, this is the way it's supposed to be arranged. Remember all the work we've done with rate, time, and distance, okay? This is that same process. Whether we're looking for rate, whether we're looking for time, whether we're looking for distance. If we go through the process of rearranging our formula, rearranging our equation at the beginning to make sure the variable we're solving for is isolated, we won't have any of that confusion about what the operations are we're supposed to do.